right. Moody is not here. Well, I'll wait. I think we start with the master students Esther first, okay? And let Moody be the last one until all the master students finish the presentation, okay? So Esther, can you start for the first presentation?
Oh, yes. Do I show my screen?
Yeah, a little bit larger, okay? A little bit larger. Yeah, sure. Thank you very much.
Number one, we need to plot the TB6 and TB3 series individual in the same diagram. And what does the diagram look like? I think the diagram look like they are all turned down.
Okay.
And number two, we need to test each series for stationarity. Use uniloop test, including intercept and chant with various leg turns. What do you find the results? The first one is for TB3. We can solve the probability, and the probability shows that we can reject the null hypothesis. So TB3 variable is stationary. Number two is for TB6. We also can see the probability shows that we can reject the null hypothesis. So TB6 variable is stationary. Number three, we need to test if the two series are co-integrated.
Okay, just a second, okay. Did you try other legs?
No, I only tried one leg.
Oh, okay. So I like to sort of saying that for this parts, actually if we're doing different legs, they're different. They may have some other result. Okay, for example, for TB3, if I using leg of 2, 3, 6, 7, 10, they are non-stationary. Okay, and if I use the TB6, okay, for 0 and 6 legs, they are non-stationary. The rest of them, I'm just trying up to 12 legs, okay, and they are all significant at 1%, 5%, and 10%. So what I'm trying to ask in this question is, I just like all of you to try different legs to see the result. Okay, then that's my point. Okay, so in this situation, for both TB3 and TB6, they are in they're stationary or non-stationary in different legs. Okay, usually the two variables if the two variables was different legs, if they're stationary with different legs, usually we like to have them to be stationary in the same legs. Okay, therefore we are trying to test the co-integration with these two series. I think this is the point for the questions. Although, if you are using different legs, the result is different. There's no problem with it. Okay. So I'm not saying this is wrong. This is correct. Okay. But you should take the time to try more legs. Okay.
Okay.
Then you'll see why I like to ask the third question, which is test for the co-integration. Okay?
Yes.
All right. Okay, go on.
Number 3, in the A part, we need to regress TB6 on TB3 time and time 2 and code a model A. And this one is my model A. The B part, we need to use unit test, including non-exogenous with various legged terms. And the probability is like this. And I think I make a wrong. So after Alice's classmates' presentation, I correct my answer. Because according to the probability it is stationary, we can accept model A is not a spurious regression. And the D part, does the long-run equivalent exist in model A? The long-run value is given the co-integrated regression, which is about 0.95%. It's like this, 0.95. And if TB3 increased by 1% and TB6 increased by 0.95% in the long run. Number 4, we need to set up the error correction model of model A. And A part run the ECN of TB6 on TB3. And this is my result from Gretel. B part, we need to explain the meaning of the coefficient of ECN. Is this one. All coefficients are individual statistically significant, and the coefficients of about 0.87 shows that a 1% increase in this one. Sorry, I don't know how to explain this. Well, on average,
this is this is the example what I give it in the class, right? So since we don't take the log,
Oh yeah, okay. Will lead on average to a 0.87% increase in this.
Okay.
And the C part explain the process from the short run to the long run equivalent relationship between TB6 and TB3. The coefficient of the error correction turn of about 0.199. 0.199 is this one. Suggests that only about 90.9% of the decreasing between long term and short term, and TB6 is corrected within a month, suggesting a slow rate of adjustment to equilibrium.
Okay.
Number 5 is granular causality test of TB6 and TB3. A part conduct the granular causality test using ECM. Set up two equations, each contains the first leg of both variables and error correction term. And this one is first regression, and this one is the second regression. And B part, it asks me, does TB6 granular cause TB3? We need to look at the second regression. We can see least coefficient is significant, so I think the result that TB6 is granular cause TB3. And the C part, it asks, does TB3 granular cause TB6? We need to seek the first regression. We can solve the TB3 is coefficient it is not significant. So the result that TB3 is not granular cause TB6. And the D part, is there bilateral relationship between TB6 and TB3? I think it is no, it is not a bilateral relationship between TB6 and TB3. Thank you.
Okay, Esther. Okay.
Yes.
Look at this. Look at the last model you just showed.
Yes.
Yeah. Okay. All right. This one and the upper one. Okay. We do need to see this whether the coefficient is significant or not. Both on the difference of the TB the leg 1 of the TB6 or TB3, including the error terms coefficient. Okay, so you need to do the joint test, not just look at the p-values. Although for your model 4, okay, the
Yes.
model 4, the dependent variable is TB3, and you look at the first leg of TB6, the difference of the first leg of TB6, and also the error terms, the first leg of the error term are all significant. And I think for the joint test is significant, I believe. Okay, for the upper one, upper one. Upper one for TB, for difference of the TB6 as a dependent variable, all right? Then you do have the TB difference for the leg of the TB3. It's not significant, right?
Yes.
But here we do have the error terms coefficient. So you need to do the joint test for the TB, the first leg of TB, the difference of the first leg of TB3, as well as the residual error terms. So I haven't seen the joint test from your report.
Oh yeah, I haven't done it.
You know, for these questions, whether we want to see the granular causalities, you need to, for the ECM, you need to do not only just the lag for the TB variable only, but also the error terms coefficient too.
Yes.
Okay, so you need to have the joint test for this two, in order to answer whether we do have the granular causality. You know, either one of the variable granular causes the other one or not. So for this example, you need to see whether TB3 granular causes TB6. You need to do the joint test for the coefficient of TB3 and also the error terms.
Okay.
You see what I'm saying here?
Yes, yes.
Yeah, okay. Okay, so have you finished?
Yes.
So what's, do they have bilateral?
No?
Okay, so your result is TB6, granular causes TB3, right?
Yes.
Okay, all right. All right, thank you.
Thank you.
Thank you. Then, Daniel?
Yes, Prof.
Yes, Prof.
Can you see my screen?
Make it larger.
Okay. Mm,
Yeah, okay, thank you.
Okay, so the first is diagram. I also just deal with they all look very alike, so they almost overlap each other. And for the second one, I also just do with one lag, and both of them have the p-value less than 1%, which indicates both of them are stationary. In other words, it doesn't have correlation. And for the third question, this is model A, which is I run based on TB6 is the dependent variable. And the B, we run the uniroot. And the C, since p-value of the uniroot of both is 1%, so it can be considered as stationary. So it means that it is not spurious. And the G one,
Okay.
it had it has long equilibrium because the model A is stationary.
Mhm.
Okay. Number 4. So we run the ECM of TB6 on TB3, and we have the coefficient of TB3 is about 0.88, shows that 1% increase of TBA of T or TBA of like 1 will be lead on average to 0.88% increase in TB6 or TBC lag 1. This is a short run of TB, but like the long run is giving in the core integrating regression, which means is both here.
Mhm. Okay.
It's like TB3 long run in TBC.
Okay.
Of the arrow correlation term about minus 1997 suggests that only about 19.97% of the discrepancy between long term and short term. TB6 is corrected with a quarter, suggesting a low rate of adjustment to equilibrium. And about
Okay.
the range causality. So this is 2 of them. And as far as I know, like TB6, because like the p-value of TB6 is less than 1%, so it will range your causes TB3. And the same way with TB3, so they are both range causing each other. So basically, they are in a bilateral relationship.
Well, let me see the result. Daniel, let me see the result for this too. You know, it seems to me that you do the same thing with Esther, but you'll have different result. Okay, make it a little bit larger, would you please?
Yes.
Okay, let's see this one, okay? So you're working with the dependent variable with the difference of TB3. Then what
Then
is your
TB6.
module A? Is the residual? The
Uh,
variable called module A is residual?
oh, the model A is like the one that were created both. Is with TB6 is the dependent variable.
But here, the dependent variable is TB3.
Yeah, and I just realized it. It seems like I was maybe even wrong.
Yeah, you need to run the TB3 as dependent variable and TB6 as independent, and time 2 are all independent variables, and get the residual
Yes.
from that model. So that model is not model A anymore. Model A is with TB6 as the dependent variable, right?
Yes.
All right.
I
And
understand.
yeah, understand that? Okay.
Yes.
So the the lower one, the model A1. So you're using the same residual. Are using the same
Yes.
residual, right? Yeah, okay.
Yes.
Okay, understand it. So you know how to do the correction, right?
Yes, and I do.
Yeah, okay. Okay.
Thanks, bro.
All right. All right, thank you. Okay, now is Linda? Linda.
Yes.
Yes, it's your turn. It's your turn.
Okay. Can you see my screen?
I haven't seen your. Okay, make it a little bit larger, please.
What?
Okay,
Can I
okay,
start?
thank you. Yeah.
Okay. And first one is the plot look like we can easily to see that it's going down. And the second is in the result we can see that the result shows us we can reject null hypothesis, so the TB3 is stationary. And the TB6 we can easily to see this result, and we also can see that we cannot reject the null hypothesis, so the TB6 is stationary. And test the two series of the co-integrator
Co-integrate.
with the or co-integrate, and the depending variable is TB6, and this is my result, which is model A. And in the bit, use the unit root test, and this is the result. We can see the result show us we cannot reject null hypothesis, so the user one is stationary. And the C is a model A spurious
Excuse me,
receipt.
excuse me,
Yes.
excuse me. What's the last parts of the B?
B. Here.
What is this one? Yeah. Use unit root test. What is this? What is this test for?
Let me see that. It is a model which I create in UST1.
So what is this? What is this?
Let me think. Oh, I think that time I just use the time TB3 plus 1 and TB6 plus 1 and contest. I
Oh, you
just a
mean the
little bit
residual?
forgot. Yeah,
The
yeah,
residual
yeah.
from model A? The residual from model A?
Oh, yes, yeah. So, I tested it's a stationary, and the C part is a super residuance. My answer is wrong. So because this model is all stationary, so it is not super residuance. And in the D part is the long run equilibrium is in model A.
Equilibrium.
Equilibrium exist in model A. So we can see the long run value in the countergrade result, which is 0.95%. And if TB3 increased by 1%, TB6 will increase by 0.95% in the long run. And the fourth part is set the error correlation model ECN of the model A. And this is my result. And the B is explain the meaning. We can see the result that are all significant, which mean 1% increase in TB3 and TB3 log. We lead on average to a 0.87 increase in TB6 and TB6 log. And the sixth part is explain the process from the short run to long run. And as a result, we can note that UA1 is 0.99, which means that the different equilibrium current on the data in only about 90.9% between long and short term within a month. And the 5% in the 5 part is contact the Granton Causality test use ECM. And this is my result. This is my model. And the answer is the TBC Granton cause TB3. My answer is yes. And the C part.
Okay, excuse me.
Yes.
Okay. What is the U hat one here?
Where is a type sent to the first part, which have a log.
Excuse me? Say it again.
Sent to the which where 在哪？
Some, you mean the model A?
Yeah,
The
sent to
residual
this part, which is
you
this
had
part and have a leg.
okay.
Yeah.
So put to the lower parts, okay.
And
So
the
now
C
you're
is my
excuse
yes.
me. Okay, upper. You know, you have to know that the dependent variables are different in these two models, right? One is TB3, the other one is TB6.
Yes.
Okay, you cannot use the same U hat one for both models.
So you mean I need to do the unit 2 for the DB6?
Maybe you had two, which using the TB3 as dependent variable and TB6 and time square are independent variables. And run that model to have the residuals instead of you had one here.
Oh.
You see what I'm saying here? You can use you had one in the lower parts, okay? If you are checking with the granular causes from TB6 to TB3, you need to run the new model for the residual. But if you are running using TB3, where the TB3 granular causes TB6, then you can use you had one.
Okay.
Okay, understand what I'm saying here? So
yeah.
I think you have the same mistakes as Daniel, but I understand these mistakes. Okay.
Okay. Thank you.
You have to understand it too, right? I understand students' mistake, but students is yourself. You have to understand your mistakes too.
Okay. And this
and
is
and you also have to do the joint test.
Yes.
Instead of just, you need to do the joint test instead of just looking at the result.
Okay,
so
okay.
for example, the first one, okay, although we know that those p value are very large, so if you are doing the joint test, I believe the joint test is not significant either, but you have to do it.
Okay.
And the second one, although the TB6 is significant, but the the U hat here is not significant, but you do need to join the test, do the join test for both of them.
Oh,
You cannot just look at this TB6 only. You know,
okay.
the example in our class, I'm not doing the gradual causality test based on ECM. Our example in the class is using gradual causality test based on yeah. Oh yes, I think we are also working with the ECM, right? Based on the ECM, right? In our examples. And I also show the joint test for this too, right? So please do the joint test again to ensure whether we have the gradual causalities between TB6 and TB3. Understand what I'm saying here?
Yes.
Okay. All right.
Okay, and there is an
Okay. All right. Then Catherine.
Yes.
It's your turn. Okay.
Okay, the first one plus the
Oh,
TB6,
yeah.
TB3.
Okay, this is real big. Wonderful. It's really big.
And in the same diagram, and it looks like they are similar and both go down. And the second one, test each series for stationary use units root test including intercept and chant with various leg turns. And this is the result. So it shows that we can reject the null hypothesis, so TB3 variables is stationary. And for TB6, and it also shows like this one, so we can reject the null hypothesis, so it's also stationary too. And the third part tests if the two series are cointegrated. So this one, dependent variable is TB6. And use unit root tests including non-externals with various leg terms. So like this one. And part C is model A specifications. And according to the probability, it is stationary, so we expect its others. Spurious regression. And the part, as we can see here, so the long run value is given the correcting regression, which is about 0.95%. So if TB6 increased by 1% and TB3 will increase by 0.95% in the long run. And set up the error correction model of model A. And dependent variable is dependence TB6. And as we can see, the coefficients are significant, and we can know if the TB6 increased by 1% and TB3 will increase by 0.87%. And explain the process from the short run to the long run equilibrium relationship between TB6 and TB3. The coefficient of error correction turn of about 0.1999679 and suggests that only about 19.9% of the discrepancy between long-term and short-term TB6 is corrected within a month, suggesting a slow rate of adjustment to equilibrium. The part 5 Granger causality test of TB6 and TB3. And this is the result. And part B, does TB6 Granger cause TB3? I think yes.
How did you know? How did you know? Where's the result shows?
The result show the
Where did you see the significant?
I think how do I explain it?
Why TB6 Granger causes TB3?
I think how can I explain it?
Where did you see the result?
I see.
I don't see the result here, right?
Yeah.
And what did the C parts? TB3 Granger causes TB6. Where is the evidence? Where is the evidence?
The evidence is
I think you are trying to use in this TB difference of the first leg of TB3.
yeah.
The probability is not significant. You're trying to use this one, right?
Yes.
But actually, you need to do the joint test.
Yes. But I do not
For the TB3,
do.
the difference of the leg of the TB, the first leg of the TB3, as well as the error correction terms.
Yes.
So you understand what I'm trying to say?
Yes, I
Do you
do.
know where's the mistakes?
Yes, I need to do another one.
Yeah, okay. All right.
Okay, thank you.
Okay, thank you. So Moody, You are the last one?
Yes, bro.
Would you please do the presentation?
Yes. Can see, bro?
No, I haven't seen the screen yet. I just see your picture only. Oh, yes, now. Would you make it larger, please?
Okay. Is it now? Okay.
Okay. All right.
Okay. Thank you, bro.
Okay.
I try to
Time begin.
explain my verse in the 1A about the graph. Based on the graph TB3 and TB6 above is a downtrend. That there is a non-stationary trend. And then the second one is about the unit root. When I use the unit root, the ADV is not significant because in 5%. And then we can not reject each null. And then when I use the leg length 1 for the unit root is significant. So I reject the each null and not reject each one. And then when I use again the leg 1 to unit root is not significant in 5%. So we cannot reject each null and reject each one. It's alternative. And then when I use length like 6 is significant in 5%. So I reject each null. And when I use test if the two series are co-integration, this you can see about C is a model is spurious regression. Yes, because it's spurious because he in the model is co-integration and the double Watson statistic law in at 0.363 is mean trend variable reduced. And then
excuse me, stop here.
Yes,
okay.
yes.
So Moody,
Yes.
is your C answer correctly?
Oh, not spurious. Not spurious. Sorry. No, it's spurious. Because in when you explain about the when it's not is spurious, it mean it's not long run equilibrium, and when it's not spurious, it's co-integration. I think I wrong in C.
Yeah, as long as they are co-integrated.
Okay.
As long as they are co-integrated, they are not spurious. The result is not, the regression's result is not spurious. So the regression is not spurious, okay? I think, you know, maybe I didn't really make this point clearly in the class. That's why, you know, all the students confused. So I like to make it clearly here that as long as you show the evidence of the regression, I mean residual of the regression is stationary, then if the original x and y variable are non-stationary, then we can say the regression is co-integrating regression, and which is not spurious. So not all the regression are spurious if their x and y variable are not non-stationary. Okay? If
Okay.
we cannot show the residual of the regression is stationary, then of course the result is spurious. But as long as we can show the result, show the evidence of co-integrating regression, then it is not spurious at all. That's very important, okay? And we want to know that regression is not spurious in order to know the long run relationship equilibrium or short run equilibrium. Okay?
Okay, thank you.
All right, and this is very important parts, okay?
Okay.
Okay, go on.
Okay, and D, does the long run equilibrium exist in model A? Yes, because value coefficient TV is 0.958. This means if variable TV increase 1%, will increase variable TB 0.95. And
Okay.
then number 4, when we set up error correlation model ECM model, run ECM TB on TB3. In this A, we have individual variable the DLNTB3 is significant and error U1 is significant. And explain the meaning of the coefficient of ECM based on result. All coefficients are individually statistic insignificant at the 5% or low level. The coefficient of about 0.47, so that 1% increase in LNTB3 will lead on average to 0.47 increase in LTB6. And then in C, explain the process from the short run to the long run equilibrium relation between TB6 on TB3. Based on the result, the coefficient of error coefficient from of about minus 0.17 suggests that only about 17% of the discrepancy between long term and the short term TB6 is corrected with quarter. Then the linear causality test TB6 and TB3. We can see the model is in TB3 is significant and error U1 is not significant. Based on the variable individual TB3 significant less than 5%, but variable integration U1 insignificant more than 5%. So we use joint significant. When we join significant, F statistic value very high, and the probability is 0.08 less than 5%. It means significant. And then when we use the dependent variable TB3, the individual variable and joint variable is significant, but I try to use the joint significant in TB 3 is at statistic is significant, and then the B, does the TB6 change cause TB3? No, because variable individual significant, but variable integration U1 insignificant. And the C, does TB3 generally costly TB6? Yes, because variable individual and variable integration is significant. Is there bilateral relationship between TB6 and TB3? No, because based on result probability, TB6 and statistic table not is not significant, and the table TB3 is significant. Thank you, Prof.
Let me see the result. Here. Okay. A little bit upper, a little bit upper.
This, oh, upper again.
Yeah, let me stop.
Yeah.
Lower, please.
This.
Lower. Lower, a little bit lower. Okay, this is the F test. Okay. How about the second one? Let me see the second one. Lower.
This the second one, and this the first one. When you want to see.
Let me see. Okay. Okay, let me see the output. Upper one.
This.
Yeah,
What?
this is okay. This is based on 6. Upper one. For the Granger causality test, how many output do you have?
Pardon?
Is this the only one output you have?
No,
Oh,
2. A and
okay.
and
Let me see the second output.
second output is TB3.
Oh, okay. Here. All right. I think you all made the same mistakes of using LN version of the TB6 and TB3, right?
Yes.
Okay. You have to use the original TB6 and TB3.
Oh.
All right. I think we
Prof, I want to ask Prof.
Yes.
Prof,
What's your question?
my question, when we use the dependent variable, the ECM, we have in the when the TB6 is dependent, I see individual variable significant, and U1 is not insignificant, right? So we use the joint significant in this model, and then when we see the variable individually significant and the integration significant, we must use joint significant or not?
We have to use the joint significance. We have to.
Oh,
we need to join significant instead of just looking at the individual one. You have to do the joint significance test for both.
Okay. Thank you, bro.
Okay, you have to do that. Look at the one without significance. You know, this the one without significance.
Yes.
You know, this one for the error correction terms is not significant.
Yes.
But the first leg of the TB3, the difference of the first leg of the TB3 are significant. So we don't know both of them jointly significant or not until you do the joint test for both of them. Okay?
Okay.
Is
okay,
this your question?
No, but yeah, but in the when we use TB dependent TB3, is significantly from individual and integration. So
yeah,
when
of course, if we do the significant test, get the significant test for individual, of course, for joint test, they will significant.
Okay.
But you still have to do the joint test.
Okay. Okay, thank you.
You see what I'm saying here?
Yes.
Although individually are significant, you still have to do the joint test. Although individually they are significant.
Okay, thank you.
You see what I'm saying here?
Yes, yes, I'm listening.
Yeah, okay. All right. Any other questions? Well, I think we finished this semester's class. Okay. And although, you know, in this semesters, we really have spent a lot of time online classes, and there's no other choice. We have to do that. Okay. And I hope you learn from this class. Do you?
Yes, bro.
A lot, bro.
Yeah, a lot.
A lot.
Yes,
A lot. I
bro.
learned.
Yeah, okay. And I really like to know some opinion from all of you, okay? So if you can write those writing, you know, wording opinions, then I'll be glad to have it. Okay, either by universities teaching evaluation forms, or maybe you can email me if you like. Okay, let me know all the results for attending this class. Okay, all right.
Can I have your email, bro?
Okay, so thank you for all of you, and I hope you really enjoy this class and also learn a lot from this class.
We do. Thank you, Professor.
Yes, bro.
Okay, thank you very much.
Thank you very much.
Let me stop the recording.
Oh.
Yes.
And